for chapter 4.7, okay, I went ahead and printed out this and I went ahead and printed out notes for you guys for this. And pretty much everything for 4.7 is all going to be about something called linear or non-linear functions. Okay, so linear or non-linear functions. So, what do you think a linear function means? A graph of a line. Okay, and non-linear would be what then? Not a line. Okay, so a linear function represents a straight line. Linear means a straight line. Okay, a straight line. A non-linear function means it's like a curve. Okay, so a non-linear function would be something like a curve. So, we want to figure out, how do we know if these tables represent a straight line or a curve? Okay, if you have something that's a straight line, what's the formula for the graph of a straight line? How do you write a straight line equation? Y equals mx plus b. Okay. What keeps something straight? Which part of this equation keeps it straight? Does the y keep it straight? Does the x? No, it's never going to be the y or the x. Those are just points. It's the m, right? You know if something is straight because it would have a consistent slope. So what we want to do here is we want to look at what's called the rate of change. Okay, so look at what's called the rate of change. Okay, so for the x, how do you get from 2 to 4?
2.
You would add 2. So we're going to look at these. Okay, how do you get from 4 to 6?
Add 2.
You would add 2. Okay, so all of these, would you agree that in the numerator, all of the x's have a similar rate of change?
Yes.
They're all exactly the same. Now you want to look at the y's. So how would you get from 2 to 20? You would add 18. How would you get from 20 to 54?
Add 18. No, let's do it.
How would you get from 20 to 54?
Add 34.
Add 34. So since these do not have a constant rate of change, would you say it is a linear or non-linear function? Non-linear, and you know that because why?
It's because it's
the rate of change is not constant. Okay, so the answer here we would say non-linear, and when it says explain, you write because B/C is like a short way of saying because. Okay, sorry, I didn't really explain that to you earlier. Because rate of change is not constant, because the rate of change is not constant. Okay? Now, technically, if we wanted to, we could actually draw these on a graph, and you would see that the line would not be completely straight. Okay? It would be a curve because it doesn't have a consistent slope or a consistent rate of change. Okay, we're going to do the same thing on number 2. Determine whether the table represents a linear or non-linear function, and explain. So, first look at the x's. How do you get from 1 to 4?
Add 3.
Add 3. How do you get from 4 to 7?
Add 3.
Add 3. So, do these, in the x part, is there a constant? Is it a constant rate of change for the x portion?
Yes.
Yes. But you also have to check the y's. How do you get from 0 to 9?
Plus 9.
Add 9. How do you get from 9 to 18?
Add 9.
Add 9. Now, just because the first 2 work, you still need to check them all. Okay, so you want to check all of them. There's never going to be more than like 4 or 5, so it's not that bad. And to get from 18 to 27, you add 9. So, is this a linear or non-linear function, and why?
Linear because it has constant.
Right. So linear because rate of change is constant. Linear because the rate of change is constant. So really all we're doing for this whole lesson is just comparing what's called the rate of change. Remember, rate of change, what's another word for rate of change?
Slope.
Slope, right.
This is easy. So
Good.
can we say the slope is?
You could say that the slope is constant. That's fine. Yeah. Okay, for number 3, it says use the table to determine whether or not the number of revolutions per hour of a second hand on a clock is a linear function of the number of hours that pass. All we're really worried about here is linear function. So again, even though this is a word problem involving a clock, even though these are a word problem, you can still look for a constant rate of change. So to get from 1 to 2 to 3 to 4 to 5, does that have a constant rate of change?
Yeah.
Yes, so these are all add 1. Okay, add 1 for all of these. The X ones are almost always, the X or the top portion is almost always going to have a constant rate of change. It's more the one in the bottom or the Y part that you really need to be checking. That's the one that would usually change. So 60 to 120, is that constant? Yes, you add 60. To get to 180, add 60. 180 to 240, add 60. 240 to 300, add 60. So, is this a linear or non-linear function?
Linear.
Linear, right.
Is this gonna be all our homework is about?
Pretty much, yep. Sorry. Yes, your homework is all going to be just like this. You are only doing 8 problems, yes.
Yay!
Okay, so the last one is a little bit more involved. Okay, let's listen. It says a square has a side of s inches. The area of the square is a function of the side length. Does this situation represent a linear or non-linear function? So what we're going to do is we're going to plug in some numbers. And I'm going to tell you, I want you to plug in for side length. I'm going to plug in 1, 2, 3, 4, and 5. So for side length, I'm going to plug in 1, 2, 3, 4, and 5. Now, if you find something in a square, okay, if we had a square that had a side length of 1, what would all the other sides equal? 1. How do you find the area of something?
Multiply.
You multiply side by side, or length times width. So what would be the area of a square, of this square? 1. What if I had a different square and its area, or excuse me, its side lengths were 2?
4.
Then what would be its area?
4.
4. So do you see how I can just take each side length and square it? Okay. What would be the area of a square with a side length of 3?
9.
Ladies, stop, please. How about the area of a square with side lengths of 4? 16. And then area of a square with side lengths of 5? 25. So, the side lengths, are they growing at a consistent rate? Yes, those are all plus 1s. But what about the area? Is it linear? This one you add 3. That one you add 5. Once you've done 2, once you get 2 that aren't the same, you don't have to keep checking the rest of them. Okay, because they won't be the same, for sure. Say it again. Right, so does this situation represent a linear or nonlinear function? So this is nonlinear, and why? Because the rate of change is not constant. The rate of change is not constant. Okay? So all we're talking about today is looking at different tables. Excuse me, I can't talk today. Looking at different tables and graphs. Well, actually, they're all tables. Okay? And determining if it represents a linear or non-linear function. Okay, just so you guys are aware. Oh, so for homework for this, just in case you haven't written it down yet, you're going to do page 331, numbers 1 through 8.
331.
Page 331, numbers 1 through 8. Yeah. 331, numbers 1 through 8.